So data science is a combination of three things basing on my experience so far. It is a union of mathematics, programming, and domain expertise, where mathematics gives you the ability to model the data that you have, the ability to understand what is inside your data, where you use functions such as mean, median, mode. You can use some bit of trigonometry or functional analysis to understand your data or model your data. Programming helps you to, to automate what you understand or automate your tasks. So you find many people program using Python, JavaScript, or any other programming language. But what is important is you should be able to automate what you understand so that it can scale or it can be used by so many people. And then the third thing is a domain expertise. You cannot be a data scientist in a particular domain, for example, fintech, or in business, or in health, or in transport, if you don't understand that domain. So if you are planning to be a data scientist, there should be a domain, a background that you base on to apply the skills in mathematics and programming so that you can solve the problems in that domain. Currently, my domain is in business and financial technologies, fintechs. So I understand so well the fintech, I understand so well business, and I can apply my mathematical skills and programming skills to solve problems using data in business and in fintech. And that's why I work with the Innovation Village and Daily Codes, because that is the domain where I fit. I cannot say that I'm an expert in health. So if, for example, there is a problem in health sector, I may not be of a good use. I may have all the skills in Pandas, NumPy, Power BI, lots of all those tools, but provided I don't understand the health sector, then I may not be of good use as a data scientist in that sector. So in this presentation, I'm going to take you through what I use day to day from the problems that I have faced. So basing on the background, I already told you that I worked with Oulu Solar, and at Oulu Solar, the problem that they were facing was customer churn, where they were losing lots of customers. Someone signs up today, after 3 weeks, they destroy their account. So that was the problem that I was to solve using data. At Ulsola also, they wanted to do credit scoring, since they were giving their devices to people, and then people would be paying in installments, and they would like to score someone to see whether the person will be likely not to pay or the person is likely to pay for the device. So those were the two challenges that I was given to work with at Oulu Solar. And there were tools that I used by then to solve the problems at Oulu Solar. Then when I went to Cognitive Insight, the major problem that I was to solve was fraud detection in financial technologies, where if you pay using your mobile money or your card, we determine whether the transaction that you are paying for is fraudulent or not. And there are also some technologies that I used to solve that problem and launch a system for cognitive insights. Then at Global Water Partnership, it was a research-based work where you are given data, satellite data, and you are to do mathematical modeling and come up with a solution that will help the government of Tanzania to 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 warn people when there is flood, so that people can remove their property and lives, so that they can be so that the government can save more property and lives. Then at the innovation village, the challenge was even bigger, because at the innovation village, my challenge was to set up a team, create a central source of truth, and then make sure that the innovation village captures data, then make sure that the innovation village is using data to drive focus and drive direction. So there are also tools that I used, and techniques that I used with CK to make sure that the team is in place and his challenge is solved, which currently I can be proud to say that close to 80% of that is done, because there is a team in place, and they are doing stuff using Power BI, and they are planning to move to ML and some other projects in the future. So I'm very contented with what I've done at the Innovation Village, and I'm now looking for another challenge, because I am a data scientist, and a data scientist is a problem solver. So the following are the tools that I always use. One, when you have a project, you're given a project, there are two things that myself I look for. One is, how will I maintain the code, versioning, and how will I collaborate? So I use GitHub or Bitbucket or GitLab to save my code and to collaborate and to continue with the versioning of the system that I use. And then I use Trello. There are several systems that you can use to manage your project. But I use Trello for my project management. I find Trello beautiful because I'm a visual person, and I find Trello more easy to use than other project management tools that I have worked with. So at the beginning of a project, I usually um, determine all the tasks that I need to do for the project, whether it is data collection, doing a survey, scrapping data from the web, um, getting information from anywhere, getting information from servers, from APIs, cleaning data. From cleaning data, do I need to do analysis? Do I need to automate my analysis? Do I need to do machine learning? How far should I go with machine learning? Do I need to deploy my machine learning? All those tasks that I am supposed to do, or I think that I'm going to do, I put in Trello so that it can help me manage my project as a data scientist. Then I use GitHub and Bitbucket to for code versioning, where I can have version 1 of the code, version 2 up to whatever version that I may reach. So at the beginning of the project, I use Git. I start a repository on Git, and I use Trello for managing my project. But you know that a data scientist does not exist if there is no data. So there are several places where people keep data. There are several sources, repositories or dumps where people store data. But so far I have worked with these three sources of data. I've worked with databases that are running on MySQL server. I've worked with databases that are running on Postgres SQL and MongoDB. MySQL is kind of old system where if you are a data scientist and you've joined a team that was here from like 2000 or before 2000, you'll find them using MySQL. as their enterprise database, and it is that database that will be running lots of queries to get information and to get insights. Then, if you join a company that is new, and their systems are new, companies that are started as from around 2005 to 2010 to now, you will find that mostly they're using Postgres databases. And your work will be mostly to query information from those databases and derive insights or build models from them. Then you may find systems that have unstructured information or semi-structured, where data is stored in JSON kind of objects, and those systems use mostly MongoDB. So I'm sharing with you these tools so that you know that as a data scientist, the the most important skill that you need to have as in your toolbox is SQL. So you must be able to program using SQL, and if you can be able to program using SQL, you can be able to interact with MySQL and PostgreSQL. There are few systems that use MongoDB, and most of them that use MongoDB, they usually don't give you access to the database itself, but they give you access to an API. So for an API is an application programming interface. The API gives you access to a database, and this API is mostly developed by software engineers on the back end. But as a data scientist, also there are some times where you are required to build an API for your models. We are going to talk about it in the coming slides. But an API is a back end of a system that gives you access to the database. And what you do is you send in a request to the API, and the API gives you back data. So for the systems that use MongoDB, they usually give you an API to work with to gather data. So the first step for a data scientist is to get to know if for the problem that you're going to work on or work with, if the data exists, and if the data exists, where is it stored? Is it stored in a database, or you can access it through APIs? When you work on a certain problem, you may be required to provide API endpoints. For example, you may work on a project, and then you create a machine learning model, and if you're working, for example, for a startup, a small company that does not have a lot of people, and does not have data engineers, you may be asked to develop an API for the model you have created, because software engineers don't understand what you are doing. You are the only person who may be understanding, or people in your team may be the only people who are understanding what you are doing in terms of artificial intelligence. And software engineers, what they want to do is to maybe display the information on a mobile app, or to display the information on a web app. So you will be tasked with developing an API for yourself. And myself, I had to teach myself Django REST framework, because I am a Python intensive person, or Python intensive data scientist. I found it easier to use Django REST framework, because it is a framework for developing APIs. But currently also I've been learning Fast API. I find it more easier currently to use Fast API to do to build APIs for your clients or for your team. So these two, in case sometime in the future you're required to deploy your model and expose API endpoints for the rest of the team or the rest of the software engineers, and you are a Python person, then you may decide to use either Django REST framework or Fast API. Fast API is so easy to use. You can learn it in less than a week. Django REST framework, I don't know, for me, it took me some time to learn it because I had to first learn Django. It took me a week to learn Django. Then it took me 2 weeks to learn Django REST framework. And since then, I've been using Django REST framework till I think 2 weeks ago when I learned about Fast API. And up to now, I'm still learning Fast API. So there is no end in learning if you are a data scientist. So I talked about the challenge that the Innovation Village gave me. The Innovation Village told me that we have data scattered in so many places. We have My Village, we have Tukole, we have Excel files, we have OneDrive, we have YouTube, we have Facebook, we have a system at the entry. When you enter the Innovation Village, at the reception, there is a system that collects data. And all this data was supposed to be in one central location. And that central location is the data warehouse. So at some point, as a data scientist, you may be interacting with the data warehouse. If you're working for an organization that has data engineers, you'll find a data warehouse created for you and you'll be accessing data marts. But if you are working for a startup, which is most probably, then everything to do with the data and creating a central source of truth will be on your head. And this means that it will be of a good advantage for you to learn some bit of data warehousing and know how to interact with data lake. So I've worked with the data warehouse, with the Innovation Village, and the data warehouse was hosted in Azure. I don't know how you pronounce Azure or Azure, but all the data streams from several locations and goes into a warehouse. When the data is in one place, it is easy for the organization to get insights from all that data and drive direction and focus for the business. Your work as a data scientist in the business is to help the stakeholders make decisions. For example, if you are at the Innovation Village, your work is to help the Innovation Village to decide whether Tech Connect is helping us achieve our aims or not. Should we continue with Tech Connect or not? But we can do that only if all the data for accounting is in one place, all the data for finance is in one place, all our social media data is in one place, all the data from even Zoom here is in one place, and we can see our progress in a 360 degrees view. Now, when you have data in the warehouse, it can be so huge. You may find that it is very hard for you to work with a lot of data at the speed that you may want to work with. Remember, we are talking about social media data, which trickles in every time. We talk about YouTube data, we talk about My Village data, and there is a lot of data that is going to our warehouse, and sometimes we may want to remove some of this data, but we want to remain with the insights on our business intelligence tools. So there are systems that I have used before to enable me work with the big data. And one of them is Apache Spark. Apache Spark, I liked it because I'm a Python person and it allows me program in Python, in Python and Scala. I have worked with Bash before. That is command line for Linux. And with Bash, we were able to program like 15 GB of a CSV file. One file was as big as 15 GB, and we were to gain insights from it from a client of ours who I cannot disclose now because I'm not allowed to disclose the project. But the project needed us to use a terminal on Linux, and we used Bash to do analysis of data. And that data was too big. It could not be loaded in Python. It was crashing the computer. It could not be loaded in R. It could not be loaded in Excel. So we could only work on the terminal to gain insights for that data. Then the other tool is Hadoop. Hadoop is good for people who are used to Java and SQL because it is an easy way for you to do analysis of big data using Hadoop if you are comfortable with SQL and Java. For a data scientist, the following programming languages are common, and I'm not going to say that one is better than the other. It depends on preference. There are people who like R to do data science. There are people who like Python, like me, to do data science. There are people who like JavaScript, Scala, Julia, Bash, and SQL. But what is important for you as a data scientist is SQL, because you'll never escape it. And it will be good for you to interact with databases. So SQL should be part of your tools, and then any of the other languages. If you are in research, R is most preferred by the researchers. The mathematicians who do a lot of research prefer R because it is easier for them to work with it to do data science, and there are lots of packages related to statistics that they can use in R. Then if you are more of an engineer, software engineer or a computer scientist, you may prefer using Python because most of the engineers like Python, where they can develop data science solutions and deploy them easily because they are packages that will help them automate in Python that are not in R. And Python, it's easy to build APIs in Python than in R. So it depends on which kind of a data scientist you are. Are you a, a data scientist who is expanding knowledge in data scientist? That in data science, I mean, those are the researchers. You may prefer R because most of the researchers like R and Julia. And then if you are a user, a data scientist who uses knowledge that is developed in data science to solve problems, then you may prefer R, you may prefer Python and JavaScript. But everyone will interact with the storage of data. That means that everyone will need knowledge for SQL. Then if you are a data scientist who interacts with lots of data, then Bash and Scala will be important in your tool set, and it will help you to do your work easily. Now, these other tools are tools that I have used to do data visualization. I know in your course for data science, you've done some bit of data visualization. It helps you to see the trends in the data. It helps you to tell stories in the data. And these are the tools that I've been using, and I always use based on the need of the organization and what the organization has in terms of their budget. So there is Chat.io. Chat.io is an online platform that connects to a database or an API and you can build visuals using SQL only, but it is not free. There is a trial version that someone can use to learn Chat.io, and it is a very easy environment to work with, and it is like my best tool, my best go-to tool if I'm to build a business intelligence system for a client. I would ask them if their budget can support Chat.io, because with Chat.io, it is live. You don't need to do lots of configuration for it to be live. When there is change of data, the charts change. Then there is Google Data Studio. This is a free tool. If you have a Gmail account, you can search for Google Data Studio and you can do your visuals on Google Data Studio. It is free and it is good for your portfolio if you're doing analysis of data and you're sharing it online. It is good for organizations that don't have budget for business intelligence. If you go there and you see there is need to have dashboards, but there is no money that can support it, you can build your dashboards using Google Data Studio. But it has a limitation. It has limitations. It's not as powerful as Chat.io or Power BI. It has some bit of limitations, but at least it can do some work and people can get insights free of charge with Google Data Studio. Then there is Power BI that the Innovation Village uses, and most of the companies that relate with Microsoft use Power BI. Power BI is easy to learn tool, but it is very powerful, and it is what most people use to do business intelligence. Power BI, you can have a free account and you can have a paid for account to have advanced features like sharing your report within your team. Then there is Tableau. I have not used Tableau a lot. I learned about Tableau, but I've not worked on an organization that needs me to use Tableau. Then the last tool is Plotly. I've developed dashboards using Plotly. Plotly Dash with Python. Since I'm a Python intensive guy, I've used Plotly with Python to build dashboards for clients. So these are the tools that I work with to show stories from data as a way of solving problems using data. Now, the other tool, when people hear about data science, they think that data science is just machine learning or deep learning. Machine learning is like is a way the machine understands patterns from the data and can be able to mimic the behavior of a human being the way it understands the data. For example, it can score a person, give someone a credit score the way a human being can give a credit score. It can identify someone's face and say it's you, basing on the way a human being understands someone's face and identify them. So these tasks that are mostly done by a human being can be done by machines through machine learning if there is enough data for the machine to get to learn the patterns within the data. So that is machine learning, and deep learning is an advanced bit of machine learning that uses neural networks, but it is it's machine learning, but an advanced bit of machine learning that uses lots of data and is mostly very accurate, basing on the amount of data to do the menial tasks that we want machines to do. So I've seen lots of data scientists focusing on only machine learning when they are learning data science. Machine learning is not the only thing in data science. In fact, you may find that machine learning is the last thing that you'll do. You may be given a project that will require you to, first of all, create a way of getting data. Then after getting data, you play with the data, gain insights, there is this phrase that I always use: from business intelligence to artificial intelligence. There is no way you can jump from from zero to artificial intelligence without passing through business intelligence. So you will work with an organization or a business to first understand the business. And how will you understand the business is by using those visual tools that I've talked about, making sure that there is a storage of data somewhere using these tools, and that data streams in somewhere on a warehouse or on a database. Then you understand the business, the trends, and you start making decisions from the trends. Then after that, you can now do machine learning to do predictive analytics, trying to understand what will be like in the future. The best example is the Innovation Village, where the first thing was to collect data and get to understand how many people are we skilling, who are we skilling, what are they interested in, when are they interested in what they are interested in. All that is done in Power BI with lots of analytics. Then from there, we will start looking at predictive analytics. How many people do you think we will skill in the next 1 year? So there is where the machine learning will come in. But before machine learning comes in, there is a lot of things that have to happen with business intelligence before you do artificial intelligence. So these are two last platforms I would like to share with you. One is Zindi and the other one is Cargo. As someone who is learning data science, or a person who is an expert in data science, we usually go to a playground. It's like EPL or Champions League. It depends on how you look at it, where there are organizations and businesses that put their data out, and then there is a challenge, a hackathon, where you are to develop machine learning algorithms or business intelligence solutions to solve the problem, and then you're given a prize. So for Africa, if you want to solve problems that are majorly for Africa, Zindi is a go-to platform. But if it is a worldwide problem, you can go to Kaggle, create an account, and participate. The good thing with these platforms, they give you data that is close to real-world data, and you can work on projects that will support your portfolio, so that one day when you go somewhere, for example, people who may come to support Innovation Village with data science, we may ask them to show us their portfolio. So you show me your GitHub, I see the projects you have been working on, I see you are a passionate data scientist. Your data, where do you get your data from? Kaggle. I see the challenges that you've been participating in and how you're ranking. And yeah, your portfolio will be shining. It doesn't matter whether you win a competition or not, but it's good to get experience and get skills from these platforms. And you can learn a lot from these platforms as a data scientist. So that is what I had to share with you as tools that I have been working with ever since I joined the army of data scientists till now. I hope it was informative, and thank you so much. Solomon, are you still here?
All right. I must say, very informative. For why I'm saying very informative, I'm looking at, questions that people have been asking. I can see have been answered today, but still, without wasting time, we can still just opening the floor to anyone who may want to, who may still have a question to ask. Please, let's ask. You can just unmute and ask if you have a question. And yeah, just like I mentioned, um, someone is saying thank you, Othieno, and I mentioned. Did I mention? I don't know. This guy is not called Othieno, but Otieno. So that's what I thought at first. But yeah, do not meet him on the streets and call him, hey, Mr. Otieno. I mean, or Mr. Othieno. So, questions, please.
Solomon, I had a question for Dalmas.
Yes, please.
Yeah, Dalmas. So first of all, thank you for that wonderful presentation. But all those tools you mentioned, so majority of the people who are just starting out in data science, they get overwhelmed when they look at all those technologies, learning Spark, something like Power BI, Hadoop, all those other tools that you have showcased. So are there specializations within data science whereby someone may first focus on certain tools in the beginning, then when they go deep into the field, that's when they can interact with others along the way. Yeah.
Thank you, Jonathan. Yes. So for data science, you don't need to learn everything at once. In my case, I had to learn bit by bit, and I began with Google Data Studio to do analysis for some company which wanted free bit of analysis for them. What I would advise someone who is beginning, don't just do courses. Yeah, you can learn all these tools at once, but it may not be useful to you. I would advise you to do a problem-based learning, where you get a problem, a challenge, and you start solving it, and you find ways of solving it. Whatever I've showcased today, I have learned all of them because there were challenges that I was given. I was given a challenge at the Innovation Village to have a central source of truth. Then I had to learn data warehousing. I was given a challenge somewhere else to handle a very huge data. Then I had to learn Bash, I had to learn Hadoop, and I had to learn Spark. Then I was given a challenge somewhere else to analyze geodata. Then I had to learn some bit of machine learning, deep learning, and I had to learn Python. So it is not that you have to learn everything at a go. You can look at what you have now. You can look at, I know how to do Power BI, or I know how to do machine learning. Then get a problem and try to solve that problem. Then get another problem. Then get another problem. After some time, 2 to 3 years from now, you'll find that you've used a lot of tools, but you didn't have to learn all of them at a go. So the first thing you have to do, one, data visualization is a very easy entry point for you to understand data science. Then the moment you are very comfortable with data visualization, then you can start doing problems as you are learning the rest of the tools. The day you will meet data to do with maybe sensors where data is too much, then you can learn Hadoop, but you don't need to overwhelm yourself. Start small, go step by step, use problems, solve problems. A data scientist is not a tool. A data scientist is not a programming language. A data scientist is a problem solver. You get a problem, then find a way of solving it using any tool. So by the time you have solved several problems, you will have interacted with a lot of tools. Don't overwhelm yourself. I hope I've answered your question, Jonathan.
Yes, you have answered it with a very wonderful response. Thank you very much.
You're welcome. Somebody asked here, Dalmas, in your work with fintech in Uganda, how are you applying data science machine learning outside credit scoring? Um, so, with the Innovation Village, the the application of data science is more of understanding the business. It's full of having dashboards that are live that show us how we are performing, um, how we are going with our plans. Is more of visualization. There is a plan of determining whether a startup will succeed or not. With cognitive insight, um, I did fraud detection where I created a system for fraud detection. If you go on most common platforms that do transactions, Jumia, um, there is Jumia, there is Sente. They hit our endpoint to determine whether you're a fraudulent person or not, whether the transaction is likely to be fraudulent or not. So that is one way. There is anti-money laundering for the banks, that the systems that we are currently building. Um, yeah, so there is lots of solutions that you can have for fintech using data science. Then, hi Dalmas, any apprenticeship or opportunity at Dalicots? Yeah, there will be some bit of apprenticeship next year, maybe as from the mid of next year going forward, because now we are overwhelmed with the systems that we're building, but we may need some interns in data science and software engineering as from mid of 2022 going forward. Then secondly, what informed your decision to choose Azure over other options such as Amazon Web? So Azure, we chose it. It's okay. That's okay. We chose Azure for the Innovation Village.
I think Dalmas.
Yes.
Before you answer that one, I think there is an upper one that gets into that. Please talk about how cloud computing comes into data science. That's from Agnes. Then you can get into that one. But before that, Gladys is happy to. She's happy she came. She had where to apply business intelligence, and yeah, you made it clear. She's happy. So to Agnes.
Yeah. So to Agnes, cloud computing is more of working with systems online that store information or code, or our systems also online. So with data science, the intersection comes in where all the information is in cloud. All your data is in cloud, and you need to understand not the whole of cloud computing, but bits of cloud computing that will help you access data. Remember, a data scientist is not a data scientist if there is no data. So your work will be legit if there is data. And you need to understand cloud computing, bits of cloud computing that require you to access data. The moment you access data, then you can apply your data science knowledge. But if you can't access data, then there is no way you have a job, there is no way you're solving a problem. Data science begins with data. So cloud computing, systems that store data in cloud, are the systems that you need to get familiar with, but not so much. If you have a data engineer in your team, then you may not need to have a lot of experience in cloud computing. Cloud computing is like a career on its own. But if you're working for a small organization, then you may need some knowledge for cloud computing as a data scientist, so that you can access that data and you can use it to solve the business problems. Now, I can now move into this question. Hi Dalmas. Where was it?
Yes.
Azure. Yes, the Azure. So Azure for the Innovation Village. We used Azure because the Innovation Village is partnering with Microsoft. It is not because of technicalities or anything, but it is because the Innovation Village works with Microsoft. The Innovation Village works with Google. But when it comes to technical abilities, the Innovation Village works with Microsoft to provide us with the internet. That is through Liquid Telecom, plus the rest of the systems. Our emails are managed by Microsoft and very, very many systems. So we use Azure because we are partnering with Microsoft. But you can use AWS as a data scientist. But remember, these cloud systems, you don't need to be fully aware of the technologies, but you need to know bits that are related to data science. For example, in Azure, there is machine learning with Azure that you can do. In AWS, I haven't interacted with it for long, so I can't tell, but I know there are solutions like Amazon RDS that will help you with your databases. Yeah, so just work with problem-based learning, problem-based working, where you're given a problem, you find a way of solving it. If the problem is to have a solution and you have enough money, a machine learning solution, and you have enough money to train it using Azure, then you train it. Then you have enough money to deploy it in AWS for your organization. The budget supports it. Then you deploy it in AWS. But there is no reason why we chose we chose Azure over AWS, which is a technical reason. It's more of partnership. Hi Dalmas, why is it that there are currently few job opportunities for data scientists in Uganda? And also, why is it that there are few training schools for data science in Uganda? One, it's because, so I faced this problem in 2019 when I came to the country, and I could not find a job by then. And I think it's because people are not so much exposed to the solutions that data science provides. And then secondly, it's because I usually say that Africans are selfish. The data is not available. So you may find that you want to expand your portfolio so that you are known, but the data is not available, and you cannot expand your portfolio if you don't have data. That's why I shared with you Zindi and Cargo. But the main problem is data science is not so much exposed. You find that it's only startups that are related to the Innovation Village, are related to Outbox, and some of these tech hubs that know about data science, and maybe banks. But the rest of the system, even the government, I have not seen a position for data scientists in the public offices. So it's just exposure for Uganda. Why is it that there is a few job opportunities? It's because of exposure. People don't know the solution. So it is us, the pioneers, who are to expose people to the solutions that we have, build a solution, show to someone the solution, then people will know about data science. Then few jobs, there are jobs that are coming up. When I came in 2019 to the country, there were very few jobs. In fact, there were no jobs. But nowadays, I think even on LinkedIn, if my thing is on, if you're seeing my screen, you can see 7 new jobs for data science in Uganda. There are jobs that are coming up, and you can always find them. There is this new one here on LinkedIn. This is a database officer, but you'll find there are jobs that are coming up, several of them in Uganda, as people get exposed. It's more of exposure to the solutions. So the world knows about data science, the world knows about the solutions that data science brings in, but Uganda is not so much exposed as compared to Kenya or Tanzania when it comes to data science. That's why the jobs are few, but they are growing. In relation to Bob Roberts' question, why is it that I think you're saying so many e-companies exaggerate the skill set required for data scientists in their job description. So the I have these are the things that I always laugh when I look at when I look at a job description. When you are hiring a data scientist, you are not hiring a data team. So all these tools I've shown you, you may find that someone knows maybe like 50% of those tools and is a fully fledged data scientist. Then some other person knows the other one. You don't need to have all the skills. They exaggerate these skills because they don't know. You may find that a company is just looking for a data scientist. They have never had a data scientist, so they think a data scientist is a god who is coming to solve all their problems in maybe even software engineering, which you are not. So it's just because they don't know what a data scientist is, who is a data engineer, who is a data architect. They don't know. So they exaggerate the skill set required for data scientists in the job description, like going as far as to machine learning engineer. So when you're a data scientist, you are expected to have some knowledge in machine learning. When you say data science, you need to have some bit of knowledge, even if it is theoretical knowledge about machine learning, so that when you have a problem, you know where to start. But there are other things that we would not expect in the job description of a data scientist. For example, I will not expect a data scientist's job description to be having JavaScript. I will not expect a job description for a data scientist to be having any of this Django REST framework or Fast API. These ones you will learn the moment you land on a problem, but it should not. It may be having a normal job description for a data scientist is, for me, if I was to write a job description, the skill set, you should be comfortable in doing mathematics because you're going to do mathematical modeling. You must be comfortable in writing a program with a computer, irrespective of the language. Can you do a loop? Can you do a while? Can you do conditions? Can you define a variable? You must understand the domain that we are in. If we are in health sector, do you have some knowledge about what we are doing, so that when you jump onto the problem, you understand the context? This I would not expect a data scientist to have knowledge in project management, because a project management is a full job for someone else, but it is an added advantage. I would expect a data scientist to have knowledge of Git, because when they work on a project, they push their code to Git for storage, for collaboration, and for versioning. I would expect a data scientist to write SQL queries, but I would not say that someone must know how the syntax of Postgres or the syntax of MySQL or MongoDB. I can ask a question like, can you write a query with a subquery? Can you join statements irrespective of which system you would like to use? So that is part of the job description skill set. I would not expect a data scientist to know how to work with APIs. This they will learn when a problem comes that needs them to work with an API. I would not expect a data scientist to do data engineering, because this putting data in the central source of truth is data engineering. But I would expect them to know how to write queries using SQL. I would not expect a data scientist to know all of this. One of them is enough. Can you program using Bash or Hadoop or Spark? Because you will use these tools in rare cases. It will be in cases where you have a lot of data, but in Uganda currently, I doubt if so many companies have lots of data. The data is so small. People started capturing data a few years ago, not a long time ago. Then with programming, now this is more of programming. I would expect a data scientist to know how to program something, to automate, because we expect automation and scalability, but not tied to any programming language. I would expect a data scientist to be able to draw for me a pie chart, a bar graph, with any of the system. Excel, you can use Excel, you can use Power BI, you can use Chat.io, but can you analyze data? If I give you data, can you bring for me insights from that data? That is it. We are not looking at the tool itself. We are looking at the problem. Can you solve the problem? If you're given a data set, can you bring for us analysis back irrespective of the tool? So this other tool will come in when now other requirements come in. For example, we want the analysis to update on its own and it should be shared by maybe 5,000 people. Then we say, okay, that can be done on Power BI or Chat.io. But in the job description is you must have analytical skills and you must be able to do visualization. Yeah, then machine learning is more of, if you are replacing someone who has been doing machine learning, then we would expect you to know machine learning. But as a data scientist, you must have some bit of knowledge on machine learning. Not everything, but know what's going on with machine learning. Because the moment you are done with visualization and business intelligence, you will move to artificial intelligence. You will not escape it. Yeah, so
No,
yes, please.
I saw an opportunity. I saw an opportunity in the previous questions that you just answered, where someone is saying, I mean, there are very few job opportunities for data science, and I'm looking at a place where there are actually so many. Nearly every company is using data, but they are not. I mean, they do not know how to use this data.
Yeah.
And I'm looking at a place where I remember when I was leaving the university, and I say to myself, I'm not going to I'm not going to be on the streets looking for a job. And to my words, I mean, I knew what I wanted, because I had in mind that I have to go out there, find a company, and tell them, this is what I can do for you. Let them know, let them understand that they need you as a data scientist. So having to explain that, I look at this field, being a new one in Uganda, it is something that we can actually do as I mean, people who are getting in this field. You can go to a company and tell them, you see, this is what you have, and this is what you can do. Without this, you cannot achieve ABCD. And I think we shall be the generation of people actually opening doors for this kind of thing.
Yeah, it is our mandate to expose. Someone will do something because they don't understand what's going on. It is up to us, who are the pioneers, to show these organizations, these companies, that this is what data science is all about. It is not like someone knows the job description of a doctor, someone knows the job description of a marketing agent, someone knows the job description of an accountant, but for a data scientist, it is not clear to lots of people. That's why you see now, like Bob is saying, I recently saw a job opportunity in the Ministry of Health for a data scientist, but they wanted a master's in data science. Yet it is a new field. Not lots of people know about data science, and not everyone is going to do a master in data science. You may find that there is someone who is more exposed in data science and has not done masters. So what for me I usually tell the founders of these businesses is, if you want someone to do for you data science, get someone who has been doing data science and you can see it on their portfolio. But if you already have a solution and you want to improve on the solution, let's say you have, this is Ministry of Health, you can determine prostate cancer with an accuracy of, let's say, 95%, and you want to improve on your accuracy from 95 to 97%. That is the point where you will now need someone who has done masters or someone who has done a PhD in mathematics or data science to help you improve on the solutions that you've built. But these other solutions can be built by data scientists who have not yet done masters. It is only that point when now we cannot go further. We need now mathematical modeling. Then we need to bring in a data scientist. But this is exposure which even the ministry does not have. You get? So it is up to us to educate the ministry that you don't really need someone who has done a master. What you need is a data scientist, someone who is working on data projects, irrespective of the course that someone did at campus or whether someone has gone to campus. Can someone solve a problem? A data scientist is a problem solver. A data scientist is not a CV. A data scientist is a problem solver. The moment you've solved the problem, you've reached a business intelligence, but you can now not do business analysis, then you can now bring in a data scientist who has done masters and can now expand further on the solution. But that is what people don't know. Kindly advise on how to choose domain expertise. So it is natural. I don't know, Rebecca Chebet, by now you belong to a certain domain. We have people who are doctors or nurses who decide to do data science. So their expertise domain is health. We have teachers who decide to do data science. So their domain of expertise is education. So it is what you have been doing and you are becoming a problem solver in that domain. You can choose any domain which you're interested in. Are you interested in business? Are you a teller? Are you working in transport? You can choose. I cannot advise on how. It is like me advising you on choosing a career. It is very hard to advise someone to choose a career. It depends on the person. But the moment you choose the domain, then you can become a problem solver in that domain. You get? I don't know if it is clear, but that is the way I go about it. Myself, I fell into business and fintech. I got to understand fintech. Then I became a problem solver in fintech. Also, some companies are still stuck on a degree in computer science for data science. A lot of exposure, yeah, that's true. A lot of exposure is needed for these companies. You really don't need, I don't feel like you need these degrees for you to have an entry level job at in a data team. You need to know how to solve problems using data, and then you have some bit of experience and you can build your own experience. You can do your own projects, publish them, and you may find that from your projects you are earning, so you may not need somebody's job. But if you need somebody's job, work on your projects, then go and show them I've been working on these projects. They will look at someone who has a CV with a master and has no project, and you who has been doing projects, like 10 projects in data science, and they will take you. The best example for me is, even though I had done a master, it was easy, but when I was doing an interview with Cognitive Insight, I showed them projects that I was working on, personal projects. So it was more easy for them to make decision to hire me because I had projects that I had worked on, and it was related to fintech. It was solving problems in fintech. I showed them this is how I can credit score and build an API on it. This is how I can build a machine learning. These are the example of machine learnings, and this is what they do. So in that interview, when they were telling me, talk about yourself, I showed them what I can do. I talked about myself. Obviously, I am getting married soon, blah, blah, blah. Then I showed them what I can do. So there, it gives you a competitive advantage over someone who has been cramming books for the rest of their lives. And I think that is a way you can go on. Don't fear these things where they tell you you must have a master in computer science or data science. Just apply for the job, because those people who have masters in computer science or data science are few. So you find that you have applied for the job, 50 of you, and none of them has that. Then they have to come down and look at now the skill set for you. So don't fear any of this job. Just dive in. Yeah, so I think we have had enough time. It's been a good session. Solomon.
Yeah, I would also like to add on that I actually know of people who went to, Coursera, Udemy, and did a course in data science when they had okay, you find the background is maybe electrical engineering and something else, and they say, I want to become a data scientist after finishing the university. Then they say, okay, I'm going to do a course on Coursera. Then I will jump into this, and within 3 months, they landed themselves a data science job, entry level.
Yeah.
But they start building from there. I have seen those. And they did not require them to have a degree in something, but if you can solve problems. So Dalmas, I think this session has been really a great one, and I want to say thank you very much for giving us. Now, why I keep saying it was very. I mean, it was a very good session for everyone here, because I've gotten so many questions around this. People who are taking the data science track, and people who are doing the cloud track, and they're saying, okay, which one should I attend? How much of cloud do I need to to become a data scientist, and all those? So I think all these questions have been answered today, and once again, thank you very much, Dalmas. Also send a vote of thanks to your fiancée, who is also my good friend. She wouldn't have allowed you to be here, but yeah, you are able to make it. So thank you.
Thank you.
And now I'm encouraging everyone.
One last thing.
Yes.
I am still asking you guys to follow me on YouTube. Currently I have 41 subscribers. That's nice. I post about data. You can get lots of information. On LinkedIn also, you will find me. You'll find Dali Codes. You can follow it.
Could you post the links on chat?
Yeah. I can, and
so
you can
go there straight away.
You can interact with me further there. We can chat, we can get to understand more about data and exposure. So it's more about exposing people in Uganda about data science and what data science can do, what a data scientist can do. And thank you so much.
All right, thank you, Dalmas. So I encourage now, part 2 of this is going to be on Saturday with Jonathan. I mean, we have, I'm looking for someone on this, on this chat. I think she left, but Janet is here. Janet leads the women tech makers, and also we have been doing this. So maybe Janet can also just post a link to those other groups, if I mean, just to make sure we do not miss. Let's join the My Village platform so that we can get here directly the next time. Otherwise, we meet. Now, on Saturday, we are going to be diving deep into Power BI. What can you do with Power BI when you're a data scientist? And Jonathan is also on this call, and he's going to be handling that. So, Jonathan, we cannot wait to see you on Saturday, and it's going to be at 11 a.m. 11 a.m. So let's follow the link. Let's watch out for the link. When it comes, then we join. Otherwise, thank you very much, everyone. Hope to see you on Saturday.
Thank you so much, and have a great day.
All right. You too.